Let us now study the shift of object due to refraction at plane surfaces. And there are two cases which we'll study here. Case 1 is the situation when object is in a denser medium. Say if we consider one side of an interface there is air with refractive index 1 and other side there's a medium with refractive index mu which is denser. It can be water or a glass slab. And within the medium, if an object is embedded and from almost near normal incident or for paraxial rays, an observer's eye we consider which is looking onto the object, and the light ray which is almost normal to the surface will be passing undeviated, and the light ray which is incident on the side of this normal ray will be refracted slightly away from normal, which will be going into the eye of observer. And all these rays which are refracted away from normal, because in this situation air is a rarer media, and all these light rays appear to be coming from this point which is shifted closer to the boundary, and I will see this point as an object which is the image, because in the eye these refracted rays are getting in, and the intersection point of all these refracted rays will be considered as image. So if object is located at a depth h below the boundary, an image is produced at a distance h prime, then as we have recently studied that the value of this h prime we can write as h multiplied by mu2 by mu1. Here the value of mu2 we can take as 1, so this will be h by mu, because the value of mu1 we are taking as mu. So the image is produced at a distance h by mu from the boundary, and the object is shifted by this distance, and here shift of object we can directly calculate as h minus h by mu, which is h multiplied by 1 minus 1 by mu. This is the shift by which the object is shifted closer to the boundary. And if we consider case 2 here, when we write object is placed in rarer medium, then in this situation, say if again say we are having air and a medium with the refractive index mu, and for air we take as refractive index 1. Now say if an object is placed at a height h above the boundary, and on the other side an observer's eye is placed, or an observer is looking onto the object, then the light rays which are falling onto the interface will bend towards normal, because the medium is denser, and all these refracted rays appear to be coming from a point which is behind the location of object, or this point will be considered as an image. So image is located at a distance h prime from the boundary. Here again h prime we can write by using the relation of refraction formula h multiplied by mu2 by mu1. Now in this situation here mu1 is considered as mu and mu2 is 1. So this will be written as h mu. So the image position will be at a distance h multiplied by refractive index, that will be more than that of object. And here if we calculate the shift of object, and the shift can be given as this is the distance by which object is shifted, which can be written as h mu minus h. So this will be h multiplied by mu minus 1. This is the shift of object away from the boundary, whereas in case when object was placed in a denser medium, its shift was toward the boundary.